I'll be going over my capstone project for Kaggle's 5-day Gen AI course. And my project is based on building a RAG based backgammon assistant. So, the problem is, as a Turkish person, I don't know how to play backgammon, which is a big kind of issue, as a lot of people know how to play backgammon in Turkey, and especially during gatherings with family or friends, eventually the backgammon board comes out at some point, and people start playing. I try to learn the rules, but every time, every time we try to play it, I forget the rules and I have to relearn the rules, and it just takes me a whole process of figuring what the rules are again and trying to play a game. But at the same time, other people have to wait for my turn, and it's just a boring process for them. So I have a solution for this problem, and that is a RAG based AI that can specifically help you in backgammon. So I call this RAGBA, short for RAG based backgammon assistant. And essentially, what this assistant can do is answer your questions about backgammon rules, and remind you how to play the game itself. But so you ask a question and it answers you directly. So in building this assistant, I went through kind of four phases that I'll be explaining here. The first phase was establishing rules and chunking, followed by creating a vector store and retrieval and generation, and finally I'll demonstrate some example questions and answers. So establishing rules and chunking. In this process, I first had to find a backgammon rulebook, and I found a rulebook for a GNU backgammon game, and this was licensed for distribution and editing and cutting out some parts. So I used this document and I cut out the rule book part specifically. And then as I couldn't feed this whole rule book into the AI system, I had to split this rule book into various different chunks. So I decided to go with chunks, which consists of 300 characters. So I divided the text into multiple chunks. I think approximately there were 24 chunks, with each having 300 characters. And notice that there's an overlap between these chunks of 50 characters. So, what this overlap essentially does is it maintains context between chunks so that when we feed these chunks into the AI system, there aren't any kind of floating chunks that appear out of place, and it helps the AI to contextualize its answers based on the chunks. Following this, I created a vector store to store these chunks. So I started out with the chunks of text. Then these were transformed into vectors by Google's embedding function. And of course, to get this embedding function in the first place, I had to open a ChromaDB client, and from the client, I got the embedding function, and using that embedding function, I finally added the vectors into a vector collection, which I also created using Chroma. So now that I had the vectors in a vector collection, now the thing that was left to do is to get a question from the user and have it answered. And at this step, we get a question from the user. For example, this can be something like, how can I win a game in backgammon? We take this question. By a similar method, we transform this question into a vector. And then this vector gets compared to all the previous vectors that we store, these chunks of text that we have in our vector collection. And Essentially, this comparison allows for semantic similarities to be found between the user's question and the information that we already have in the vector collection. So once this comparison is done, we get a bunch of responses from the vector collection, and what the collection returns is a bunch of relevant chunks that it thinks is related to the user's question. So we get these chunks in return, and then we combine these chunks into an answer, which is then placed into a JSON structure, and the system, the AI system, uses this structure to provide the final answer to the user. And here are some example uses that I these are some questions I asked and the answers I got in response. So for when I asked what is backgammon, I got backgammon is a game for two players played on a board consisting of 24 narrow triangles called points, and so on. And another question I asked was how can I win a game in backgammon? The answer to this was pretty concise. It said the first player to bear off all 15 checkers wins the game. And another question I asked was what is bearing off in backgammon, kind of piggybacking off the last question. And then it answered once a player has moved all of his 15 checkers into his home board, he may commence bearing off. A player bears off a checker by rolling a number that corresponds to the point on which a checker resides and then removing that checker from the board. So these were all some of the, the questions that I tested, but of course there were some questions that I couldn't answer as they weren't in the rule book. For example, when I asked the question, what's the way that the game moves, and it wasn't able to answer that question. Instead, it gave a related answer that it found in the chunks, but it wasn't an answer that I was looking for directly. So it obviously has some limitations and hiccups that need to be fixed. So yeah, this was my capstone project, a backgammon assistant, and that was how I went through building it. And yep,